Software design is concerned with deriving a solution which satisfies software requirements. A software design can be traced to a customer's requirements. The designer's goal is to produce a model or representation of an entity that will later be built. The design process. Software design is an iterative process through which requirements are translated into a blueprint for software to be developed. We start the design with high level of abstraction, which means that the initial design represents the entire system. Initial design can be directly traced to specific data, functional and behavioral requirements. As design iteration occurs, subsequent refinement leads to design representations at much lower levels of abstraction. Move to our next topic, that is effective modular design. Functional independence is a direct outgrowth of modularity. Functional independence is achieved by developing modules with single-minded functions. Functional independence is measured using two qualitative criteria: cohesion and coupling. Let us see what cohesion is. The cohesion of a component is a measure of the closeness of the relationship between its elements. That is, it is the degree to which a module performs one and only one function. A component should implement a single logical function or should implement a single logical entity. There can be 7 types of cohesion. Number 1. Coincidental cohesion. Number 2. Logical cohesion. Number 3. Temporal cohesion. Number 4. Procedural cohesion. Number 5. Communicational cohesion. Number 6. Informational cohesion. And number 7. Functional cohesion. Design heuristics for effective modularity. Evaluate the first iteration of the program structure to reduce coupling and improve cohesion. Attempt to minimize structures with high fan-out. Strive for fan-in as depth increases. Keep scope of effect of a module within the scope of control of that module. Evaluate module interface to reduce complexity and redundancy and improve consistency. Define modules whose function is predictable but avoid modules that are overly restricted. Design modules which have high cohesion and weak coupling. Design model. The figure on your screen shows the design model. At the base of design model is the data design, architectural design interface design, and procedural design complete the design model pyramid. Each of the elements of the analysis model provides information that is required to create a design model. In the data design, data structures are created that will be required to implement the software. Data dictionary and ERD are the basis for data design. The architecture design defines the relationship among major structural elements of the problem. The design representation, a modular framework of a computer program, can be derived from analysis models and the interaction between subsystems defined within the analysis model. During architecture design, generally subsystems are identified and a framework for subsystem control and communication is established. The interface design describes how the software communicates within itself to systems that interoperate with it, and with users. An interface implies flow of information, data control. Therefore, the data and control flow diagrams provide the information required for interface design. The component level or procedural design transforms structural elements of the program architecture into procedural description of software components. Information obtained from PSpec, CSpec, and STD serve as the basis for procedural design.